On this page of notes, I have a short example problem for us to look at, but it emphasizes how those simple equations that we've already talked about on these first couple pages of notes are then used in a real-life situation and the language that we use when referring to them. So let's see what we have here. We are given that when a battery is discharging, so in the discharging case, we know that it's the terminal voltage is going to be less than the EMF by the amount, I little r, if we have internal resistance, which we will in this case. Now, we're given that the current being drawn by the battery is the 0.15 amps, and we're told that the potential difference across the terminals, so that's this one, is the 0.14, and we're told that the joule heating rate of the battery is the 0.014 watts. Now, this is where the language becomes really important. First of all, anytime we have heating rate, that's the rate at which energy is being used, that is going to be a power equation. So recalling our power equation, power equals IV equals I squared R equals V squared on R. So when we're talking about the power being dissipated or generated, the energy rate, we have to associate this power with either the power associated with the terminal voltage, the power associated with the EMF, or the power associated with the internal resistance. In this case, they're telling us that it's the power related to the internal resistance. So it's the I squared R, and look, they give us the I. So we are going to be in business by using our discharging voltage equation to finish this problem, and then you can take a look in part B. What is the rate at which chemical energy is stored? And this is, again, the language part. Energy rate is always power stored in the cell. The cell itself is the EMF. So that's why we're looking at the power associated with the EMF. So you can take a moment and finish your calculations for this page, pause it, and I will show you the solutions after you unpause. So pause the video. Okay, hopefully you have completed your calculations. You can check them with the answers here, and we are going to continue to move on.